February 6, 2023. Weaving History. How binary coding transformed the world. Did you know that early computer programming was inspired by an 1804 invention for weaving fabric? 200 years ago, long before the earliest computers, making goods was often a slow and expensive process. For example, weaving fabric was not an easy or quick task. People could use machines called looms to weave fabric, but early looms were operated only by hand. Plus, some patterned fabrics needed two or more skilled people to weave them. It took years of training to become skilled in weaving. Look at this picture of a person weaving a pattern by hand. In the picture, the weaver lifts up certain threads. These pink threads are web threads. To create a pattern, the weaver must lift different web threads at different times, and then push the colored pattern thread through underneath them. The piece of cloth being created in this picture is small. For larger pieces of cloth and more complex patterns, the weaver would need a larger loom to hold the web threads, and more people helping to lift them. Because it required many people with a lot of experience, weaving fabric with patterns was very slow and expensive. As a result, all fabric was expensive, especially patterned fabric. Fabric with patterns was so expensive that only wealthy people could afford it. In the mid 1700s, inventors were focused on finding ways to make things quickly and cheaply, but no one had invented a machine to weave fabric quickly yet. That changed in 1804. That year, a Frenchman named Jasper Marie Jacquard invented a machine that could make a loom automatically weave a pattern into fabric. This meant that patterned fabric could be woven easily and quickly. Jacquard's machine used a set of cards with holes punched in them. The holes were punched in a special code that forced the loom to weave the pattern instead of just weaving plain cloth. When there was a hole in the card, a hook on the machine would pass through it and lift a thread. When there was no hole, the hook would be stopped, so no thread would be lifted. The machine was responding to only two commands, either a punched hole or no punched hole. This type of two command system is known as a binary code. The invention of this machine meant that looms could be run by factory workers with less training than skilled weavers. It also meant that fabric with patterns could be woven more than 20 times faster. All of this helped make patterned fabric less expensive to buy. This invention also marked a really important change in humans' understanding of the complex tasks machines could do. If holes punched in cars could tell a loom how to weave a pattern, what else could they do? Other inventors began thinking about how they could use punch cards and binary code for different purposes. One of these inventors was Carlos Babbage. Babbage began working on his analytical, analytical engine, engine in the 1830s, generally considered to be the first computer. The analytical engine was designed to do highly complex math. Babbage was greatly inspired by the Jacquard loom, and he planned to use punch cards to submit both instructions and date to his analytical engine. The calculations the machine would produce were intended to create mathematical tables for engineering, navigation, and science. Ada Lovelace, often considered the first computer programmer, was also inspired by the punch cards. She realized binary code could be used for any kind of information. She created a program for Babbage's analytical engine and wrote, "The analytical engine waves algebraic patterns just as the Jacquard loom waves flowers and leaves." When she thought about other things punch cards could do, she said that the two numbers in a binary code could be combined to stand for letters, symbols, or even musical notes. This was an important change in how people viewed numbers and symbols. Instead of only being used for math, binary code could be used to do almost anything. Binary code is also used in art, like in the photo above. This image shows a quilt, a quilt called "Smart is Beautiful", made by the artist Thomas Connor for his daughter. Quilts are made of three layers sewn together, a top and bottom layer of fabric that sandwich a soft inside layer called batting. On the top layer of "Smart is Beautiful", Cornell used white squares to write a secret message in binary code. In the quilt, each quilt block is made up of colorful stripes with a pattern of small red squares set in two rows. One row represents ones and the other row represents zeros. By reading the pattern of zeros and ones, the viewer can read the message in a binary code called the American Standard Code for Information Interchange, or ASCII. Each of the 16 squares in the quiz stands for an ASCII letter in the sentence "Smart is beautiful." Cornell used the code in his quiz to tell his daughter that being smart is one way to be beautiful. People who make quizzes often include designs that have special meaning to them or to the person for whom the quilt is made. Thank you for watching.